how to solve a problem about fluid mechanics, particularly in properties of fluids. So we have here our problem. Blimp is an airship that maintains its form by pressure from contained gas. In various athletic events, they use helium-filled blimp in which the helium gives the aircraft buoyancy in the air, just as floating ship has buoyancy in the water. Determine the volume of the helium within a blimp in an athletic event if the weight of the helium is 490.5 pounds and the temperature and pressure is 88 degrees Fahrenheit and 16 pounds per square inch respectively. So we have here our identified given for this problem, the weight which is 490.5 pounds and the temperature 88 degrees Fahrenheit and our pressure 16 pounds per square inch. So we are going to identify first the specific weight of our helium. So we know that specific weight is density times gravitational acceleration. So since this problem involves a gas, we are going to solve our density with this equation here. Pressure all over the product of the gas constant and its temperature. So our pressure is 16 psia over the gas constant. It is not given here in this problem, but we know that the gas constant for our helium is 1.242 times 10 raised to the power of 4 feet-pound per slug Rankine, and then multiplied to the temperature which is 88 degrees Fahrenheit, and we are going to add 460 to convert it into Rankine so that our units will match to solve our needed here. And we have here 16 pound per square inch, so we also need to convert this into pound per square feet. So we are going to multiply it with 144 square inch. And by that, since we have this equation here for our density, we are now going to multiply it with the gravitational acceleration, 32.2 feet per square second. And we will get that our specific weight is actually 0.0109 slug square feet square second. But we all know that the unit for specific weight is pound per cubic feet. And we know that 1 pound is equivalent to 1 slug feet per square second. So we can actually cancel out the slug here and the squared second, and we will get that our specific weight is 0.0109 pound per cubic feet. And since we already have our specific weight and we are actually looking for the volume of the helium within the blimp, we are going to come back here, and we know that weight is equals to mass times gravitational acceleration, and we know that mass is equals to density times the volume, and we know that density and gravitational acceleration is this specific weight. And by that, we already have our specific weight since we have already solved for it a while ago. And now we are left with our specific weight and our volume, and also our weight on the other side. But we know that we have our weight and we also have our specific weight. Now we can actually find our volume. So substituting the values for our weight and our specific weight, we can get our volume. So we are just going to divide our weight, 490.5 pound. Pound is actually slug feet per second square. It is actually given here, right? So we can actually cancel out the pounds, and we will get that our volume is cubic feet. Volume is 45,000 cubic feet. So this is the answer for this problem.